In this section 8.5, we're going to take a look at some of the applications of 3 equations, 3 unknowns. We're going to take a look at a couple of exercises very similar to the ones you're doing for your homework. The idea is to give you some exposure as to where something like this could become beneficial or useful in our work. Okay, so let's take a look at this example. This is again exercise number 9 in section 8.5 of your textbook. So in this exercise, the question reads, in a triangle ABC, the measure of angle B is 3 times that of angle A. The measure of angle C is 20 degrees more than that of angle A. Find the angle measures. That is the 3 measures for A, B, and C. Okay, so we're going to set this up within the confines of 3 equations, 3 unknowns. Notice there's not much wording here, but out of these, we will be able to get 3 equations, 3 unknowns. Let's see how. So our first equation comes from right in here. In a triangle, the measure of angle B is 3 times that of angle A. So the word is a keyword for us. Okay, so that word is right in here. Is, that means equals. And we always look for those keywords when we translate these word problems into mathematical expressions. So let me write an equation for that. Measure of angle B is, so I'm going to write B is 3 times that of angle A. So that would be 3A, wouldn't it? The measure of angle C is 20 degrees more than. So again, the keywords here, clearly up here, times means multiplication. More than means addition, right? So these keywords are what translate into the operation symbols in our mathematical expressions. The measure of angle C is 20 degrees more than A, so that's going to be A plus 20 or 20 plus A. So that would be 2 equations. Now, we need a third equation that's not in there, right? We're done with all the phrases in the problem. So where's that third equation going to come from, right? Well, in a Euclidean geometry, which is what we're in, we know as a common knowledge that sum of the interior angles in any triangle has to be 180 degrees, right? So the measures of A plus B plus C should be 180 degrees. We take that to be a common knowledge. If we didn't know about it, we wouldn't be able to set up the system. Now, once I have the system, then I can solve this easily, because if you note, B is stated in terms of A, so is C. Both of those are stated in terms of A. So I can actually, I can actually substitute for B and C into the third equation, and that's exactly what I'm going to do. So the equation becomes A plus. Instead of B, I'm going to write 3A, right, plus. And instead of C, I'm going to put A plus 20. That is, of course, in the third and the last equation, right in here. So there, I get 180. Note we have an expression entirely made up of A, just one variable A. Next step is to combine like terms. A, 3A, and A makes 5A plus 20 equals 180. And if I subtract 20 from both sides, I get 160. And divide by 5, that would give me what? 5 times, oh, sorry, not 5. I'm dividing both sides by 5. So 160 divided by 5, I believe that's what? 32? So the measure of angle A is 32 degrees. Now, once we have the measure of angle A, we can substitute for A in here and solve for B. Therefore, measure of angle B is going to be 3 times that of A, and that makes it 96 degrees. The measure of angle C is that of A plus 20, and A was 32. 32 and 20 makes 52 degrees. And there we have solved the system. So those are the three measures of the angles, A, B, and C. If we add them, clearly they add to 180, right? Because in here 30 and 50, that's 84, and 96, 180 degrees. And there you have it. So that's what that would be. And if I draw this triangle ABC, let's say in this form, the largest angle is 96 degrees. That's going to be a 96 degree angle. Then this is a, let's say, 52 degree measure. This is going to be C. This is B, and this is the measure of A. Turned out to be 32 degrees. 32 and 52. So that's how this triangle is, which we call it in geometry a scalene triangle. Okay, scalene. Just to mention the word. Okay, and there we solved the system. So here's an example where three equations, three unknowns could be used to solve the system. Now, let me bring up this other. This is our last example from this section. So now in this example, this is something that's markedly different than the one we just did. So let's take a look at this example now. In this exercise, this is number 23. Number 24, by the way, is very similar to this. And again, this is one of your homework problems, I believe, that you're working. So let's work these together. In exercise number 23, a dietitian in a hospital prepares meals under the guidance of a physician. Suppose for the particular patient, a physician prescribes a meal to have 800 calories, 55 grams of let me just underline these key information. 55 grams of protein, 220 milligrams of vitamin C. The dietitian prepares a meal of roast beef, baked potatoes, and broccoli according to the data in the following table. And here is the information. Now, of course, the question right in here, obvious. How many servings of each food needed in order to satisfy the doctor's order? So ultimately, that's what we would like to do. Now, our A, B, C's or X, Y, Z's, let's call this X, Y, and Z. So X would be the number of servings of roast beef, Y for baked potatoes, and Z number of servings of broccoli. Now, let's take a look and see how we're going to set up the constraints or equations in the system. First of all, for calories, the patient is required to take 800 calories, right? Where the sources of the calorie for this patient is going to come from those three food categories, correct? So for example, if the patient, if you give this patient one serving of roast beef, let me write that, 1 times 300, that makes 300 calories, right? If the patient takes 2 servings of roast beef, that gives him or her 600 calories. For 3 servings, 3 times 3, 900 calories, which exceeds, right? So, but that's nonetheless, that's how we figure out the amount of calorie intake for so many servings of roast beef. So I'm going to set up the system. We're going to have to set it up like this. 300x. This would be the number of calories that will be consumed or taken in for X servings of roast beef. Now, baked potatoes are 100 per baked potatoes. So again, just like the one above, 2 baked potatoes gives the patient 200 calories. 3 baked potatoes gives them 300 calories, and so on. So since we don't know how many servings, I'm going to call that Y. So 100Y would be the number of calories due to Y baked potatoes. And likewise, if I do 50Z, that would be the total calories from so many servings of broccoli, right? Now we add them because the patient is going to be served a meal that's made up of those 3 ingredients, and assuming the patient actually eats all those 3. So the sum of these calories should be 800. Now similarly, we can do this for for protein intake, right? The protein, 55 grams. So here's where the protein sources are. And for each servings, that's how many grams of protein the patient is going to take. So 20x plus 5y plus 5z gives you the amount of protein was 55 grams. Those should add up to 55. And for vitamin C, right in here, the vitamin C intake, that's going to be what, 220 milligrams of vitamin C. So I'm going to go ahead and put let's say 0. That's the amount of vitamin C that's in roast beef. Roast beef is a meat, it does not have vitamin C, but there you go, 0x, that would be the total vitamin C received from roast beef. And then 20y, the amount of vitamin C due to baked potatoes. And 100z is the amount of vitamin C for so many servings of broccoli. These totals, we're told, should add up to 220. So that, I'm going to set that equal to 220. And there you go. Again, we set up our system. Now we need to solve the system here. Okay, now 0x here is just 0, right? So in the next step, I'm just going to leave that out. Also, we like working with smaller numbers. So I'm going to reduce every equation here, like the first equation. If you look at the first equation, 300, 100, 50, 800, these numbers. The GCF, the greatest common factor between these, is 50, isn't it? So let's make this a little smaller. The coefficients, that is, make them smaller. And sorry about that. I'm going to divide the first equation, everything, by 50. Okay, so when we divide everything now by 50 in the first equation, that's going to make it, our first equation, that's going to be what, 6x plus 2y plus z equals 800 divided by 50. And that's going to be what, if you do long division, 800 by 50, that's the same as 80 divided by 5. It's going to be 16, right? I'm just going to show you how that's done. There you go. Okay, 16 equals 16. So no calculator necessary here. And there we have it. So we reduced the coefficients. Same thing with the second equation. If you look at the GCF of 25, 5, 55, 5 is the GCF. So I'm going to, in the second equation, divide everything by 5. And we divide everything by 5. What we're going to get is, indeed here, that's going to make it 4x plus y plus z equals 11, right? Divided by 5. And finally, the third equation, that's this one right in here, this one. The GCF is going to be 20. So divide by 20, we're going to get just y plus 5z equals 220 divided by 20 is 11. And there you have it. Now, much better, much smaller numbers. Notice, by the way, and now we're about to solve this, right? If you look at this equation, it's already solved for y and z, right? There's no x in it. So let's pair these two equations together, right? The first two equations. And in it, eliminate x. Now, in order to eliminate x here, let me first write them, pair them together, and see how we're going to do this. So I have 6x plus 2y plus z equals 16. 4x plus y plus z equals 11. Okay. Now, in order to get rid of the x here, we need opposites, right? So what we do, in fact, now we find the LCM, the least common multiple of 4 and 6 is 12. So we're going to build those two numbers to 12. Okay. So I'm going to multiply the top equation by 3, negative 3, the bottom by 2. See, my focus is right in here. And don't worry about these. Our focus is on just the x's. We want to eliminate the x's. So I'm thinking, how can I get opposites here? And the way I did it is the way to get opposites. So that's the motivation for what to multiply by. Okay. Now, let me actually clear this extra stuff here so it's not so cluttered. All right, let's do the multiplication. Negative 3 times the first equation. That's negative 18x. I'm sorry, I didn't multiply, but I did mention it, but I just didn't do it. Sorry. I'm sure everybody caught that one, right? I needed a 12, so I got to multiply the top by 2, the bottom by 3. That will do it. Okay. And this is how I get opposites now. Both of those are 12 and negative 12. They add to 0. Okay, well, let's complete it. 2 times 6, that's negative 12x. Negative 4y, negative 2z equals negative 32. 3 times 4 is 12x plus 3y plus 3z's equal to 33. And then add them together. And here these add to 0 because they're opposites. Negative 4 and 3. That adds to just negative y, and then plus z equals to 1. Okay, negative y plus z is equal to 1, and that will give me my second equation. Okay, so I'm going to pair them together now. Y plus 5z equals 11. Negative y plus z is equal to 11 also. Now, I'm pairing these two. See, as long as I have two equations with the same variables. Now I'm going to solve this system by elimination method. And all it takes is just adding them, right? So I'm just going to add those together. These add to 0, so that makes it 6z equals to 22. And z is equal to 22/6 here. Okay. And actually, let me backtrack here. Sorry, because I just realized right in here this is a 1, and I copied it as 11. So that means let me correct this one. Fix this one up. This part is incorrect, and all I have to do is just make that 1. Sorry about that. I'm sure most of you caught that, right? Okay. So there we have the 1. Again, that's not 11. My process hasn't changed though. I'm going to add the two equations, and this time when I do, I get 6z equals to 12. Now that's better, because it was getting fractions and that didn't seem right. 12 divided by 6, 2. So there you go. Now remember, z was the number of servings of broccoli. So 2 servings of broccoli. And now we are in a situation or in a position to where we can actually back substitute and solve for y. Negative y plus z equal 1. So negative y, subtract 2 from both sides, makes negative 1. And here from this, y must be 1. And there we have it. So we've got that part all figured out. Okay, so y is equal to 1. And once we have the solution to y and z, we can back substitute into, let's say up here, into either of those two equations. The easier of the two is what? 4x plus y plus z equal 11. So that's the one I'm going to plug into. 4x plus y plus z equals 11. And x is the unknown. Y turned out to be 1, right? Right in here, y is 1, and z is 2, equal 11. So from this, we can now, 1 and 2 makes 3, subtract 3 from both sides, and this leads to the solution, divide by 4. The solution is 2 for x. And there we go, we've solved this. The solution to the system is ordered triple again, 2, 1, 2. So that's how many servings of roast beef, right? That's how many servings of roast beef. This was baked potato, and this one was everyone's favorite, broccoli. Okay, and with that, now we are done with this section. Okay.